welcome to Shri Sathya Loka Seva Gurukulam online classes. So let's move on with today's class. We've been learning limits and continuity. In the last class, we saw what is continuity, and we are going to continue with the same concept in today's class. So the first question for the day is, by means of graph, discuss the continuity of the function f of x is equal to x square minus 1 by x minus 1. So we're going to see whether this particular function is continuous. So let's see how we are going to do it. So now let's plot it on a graph and then read the graph and see whether it is continuous, because it says with the graph discuss the continuity of the function. How do you graph this function? Your f of x is equal to x square minus 1 by x minus 1. Now you give values for x and find the relevant f of x values and find the coordinates first before you plot it on the graph. So let's start giving values. So we'll give minus 1 first to x. When you give minus 1, your f of minus 1 is going to be minus 1 the whole square minus 1 by 1 minus 1 minus 1. So that is equal to plus 1 minus 1 by minus 2. That's 0 by minus 2, 0. So here it is minus 1, this is 0. So we make a point on the graph, minus 1 comma 0. So your x is x and this is your f of x or y. Now next we'll give 0 to x. So when I give 0 to x, f of 0 is going to be 0 minus 1 by 0 minus 1, and that's going to be equal to 1. So my next point on the graph is going to be 0 comma 1. So now let me substitute 1 on the graph and see. So my f of 1 is going to be 1 minus 1 by 1 minus 1, which is 0 by 0. Actually, it is indeterminate. I don't know what's happening, so I'm putting a gap there because the value is unknown. So beyond that, we are plotting it and we get a graph like this. So the graph of the function that's shown in the adjoining figure, the function is actually discontinuous as there is a gap in the graph at x is equal to 1. Is it right? Okay, we'll move on. What does this mean? Since it is indeterminate, we cannot determine that way. So now if we rewrite this and see what is happening to the function at exactly. So to remove this discontinuity, what can we do? There is a discontinuity here. So now we are going to see the removal of discontinuity. We are going to rewrite the function if possible and try to find the value of f of 1. So what do I do? F of x is equal to x square minus 1 by x minus 1. So let me factorize the numerator. I have x minus 1 by x plus 1 and x minus 1 on the denominator. I cancel it out and I get x plus 1. So now if I substitute 1 there, I have f of x is equal to 2. So if I redefine my function like this, f of x is equal to x square minus 1 by x minus 1 when x is not equal to 1 and is equal to 2 when x is equal to 1, then I can remove this discontinuity and I can mark it as 2 and make the graph continuous. So this is how we remove the discontinuity of the function by redefining the function according to its existence. I hope you understood. Let's move on to the next question. Show that e power minus 2x plus 5 is a continuous function. Now let's see how we are going to show it. So for us to show this, how do we show that a function is continuous? We need to show limit x tending to a, f of x is equal to f of a. So now he says, to show that the function is continuous. No particular point is given. So we need to check the entire real number system whether this is continuous or is it not continuous in any point in time, okay, or any point, any value, it is not continuous. Let's see. Now let's take in our A in R and observe the function. Now limit x tending to A, f of A is going to be e power minus 2a plus 5. So this definitely exists, it's a real number. Exponential functions are defined in entire real number system. They are always, all exponential functions are always positive. So we have got this. Now next, now we need to check if it is equal to f of A. Now what is f of A? Instead of ax, we are going to replace a again. So from here it is very clear that limit x tending to A, f of A is equal to, f of x is equal to f of A, and this implies the function is continuous. Let's move on to the next question. So the question says, by means of graph, examine the continuity of each of the following functions. So we are going to graph it. Now, before we graph it, we'll try to find the coordinates. So we'll give values for x and find the corresponding f of x value. So when I put x, let's take some small numbers, minus 1, 0, 1. We'll take three values of x. So at x is equal to minus 1, my f of x is going to be 0. Now when my f of x is, my x is 0, my f of x is going to be 1. When my x is 1, my f of x is going to be 2. So let me now plot it on the graph. X dash, y dash, 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3 here. Okay, so now let's plot minus 1 comma 0. So minus 1 comma 0 is 0. My next coordinate is 0 comma 1. So 0 comma 1 is here. My next is 1 comma 2. So it's going to be here. So when I join it, I can see it has to be accurate, children. When you put it with a pencil and a ruler, it comes out right. So this is how your graph will look. It's of course continuous. So it's going to give you a continuous function. Most of your, all your polynomial functions are continuous. So let's move on to the next question. Now f of x is equal to x plus 2 by x minus 2. This is a rational function. So let's see whether it's going to be continuous or not. So let's take values of x and find our f of x values. So we'll take it from minus 2, minus 1, 0, 1 and 2. And we'll also take it at 3. Let's see what we are getting. So why am I taking so many values? You will get to know when I plot it. Now minus 2, when my x is minus 2, my f of x is going to be minus 2 plus 2 minus 4. So this is anyway 0 by 4, it's 0. 0 by minus 4, it's 0. Now minus 1 when I give, it will be minus 1 plus 2 by minus 1 minus 2. So this is going to be 1 by minus 3. Minus 1 by 3. So this we will avoid plotting because it's a little difficult to plot such fractions on the graph. Now when I put 0, it's going to be 2 by minus 2, it's minus 1. Then it's 1 when I substitute for x, I get 1 plus 2 by 1 minus 2, that is 3 by minus 1, that is minus 3. Now when I put a value of 2 there, it's going to be 4 by 2 minus 2, that's 4 by 0. Anything by 0 is infinity. So now 3. When I put 3 there, it's 5 by 3 minus 2, that's 1. So this is going to be 5. So let me plot this graph and see what happens. So my y value goes on till 5, my f of x. So I have 0, minus 1, minus 2, minus 3 here. And then 1, 2, 3. I'll extend it because I need it till 5. 4, 5. Then this side I have negative till minus 2. So it's minus 1, minus 2, minus 3, then 1, 2 and 3. Let me plot it. Minus 2 comma 0. So this is going to be here. Minus that I'm going to skip. This I'm going to skip. 0 comma minus 1. It's going to be here. Then it's 1 comma minus 3. 1 comma minus 3 is going to be here. And 2 comma infinity. So it's going to go on somewhere here. Infinity. It just falls on to infinity where it is not defined. Right? I'm not be able to plot it. So and 3 comma 5. Then it starts from here. So obviously you can see that there is a like this. And then from here you're going to start again. Correct? When I put my 3 there, it becomes 5 by 1. It's 5. So again 3 comma 5, from there it starts. Obviously you can see that there's a discontinuity there. So this f of x is equal to x plus 2 by x minus 2 is not continuous at x is equal to 2. So I hope you all understood. We've seen what is the continuity today, how to remove the discontinuity, how to graph it, and how to see on a graph whether the function is continuous or not. So examine the graph and understand the basic discontinuity, and then how to remove it also we've seen today. So if you've not understood any part of the class, please do go back, see it again and again, and try to comprehend the concepts. Thank you. Sayonara.